Hello, my name is Jarman. I am from the UK Hydrographic Office as a geospatial information specialist with a focus in bathymetric survey science. Over time, we've seen a shift from physical data to digital data, moving from compact disks and hard drives to cloud-based storage with security encryptions. This allows for much larger volumes of data to be transferred more efficiently. As a result, latency is reduced, decision-making is faster, and multiple applications can use the same information. We've also seen changes in user experience, from mouse-based interaction to touchscreen applications, supported by a wide range of tools for creating charts and maps. I believe that this will extend further into the future. Starting with the next 10 years, we can be expecting mapping and charting to become increasingly vital through the continued growth with digital applications. This includes geospatial integration. This allows users to be able to view multiple aspects of data across the same geographic area more efficiently and intuitively. For example, navigational users will be able to overlay and switch different information views, ranging from topography and bathymetry to more detailed features such as routes and points of interest. This approach reduces clutter often associated with busy maps charts and enhances the visibility of key information. We also have been seeing more use of automation in processes, allowing for faster production, enabling improved efficiency with cartography updates. Looking ahead 20 years, I would expect to see significantly greater adoption of autonomous data collection. This would allow for the data to flow seamlessly from the collection point to processing and verification, and ultimately to being plotted. With help from AI as a key development feature, autonomy would increasingly extend into charting workflows, improving efficiency and consistency. Alongside AI-supported regular data collection, the growing availability of historical datasets would enable the ability to forecast changes in mapping or charting. For example, predicting seabed changes of sound wave mobility can enhance routing, making it far safer for navigation. Users could interact with this information through tools such as the time slider, allowing them to move through historical datasets and project forward to visualize likely future conditions. At the 30-year point, I expect to see augmented reality, or AR, to be a major component of how maps and charts will be used. AR will reduce the limitations of a fixed screen, allowing key information to be overlaid directly within a user's field of view. Whether operating on the ground, within a vehicle, or in an office environment, visualization will become increasingly three-dimensional, enabling users to view multiple perspectives and identify critical information faster. We would also see greater integration between different types of data, with organizational datasets brought together into a single, cohesive visual environment. This would improve usability and reduce latency, allowing navigational routes and bathymetric depth information to be viewed alongside aerial or satellite imagery and land-based mapping. Despite these advances in automation and visualization, charts and maps would continue to rely on human oversight and interpretation to ensure confidence, accuracy, and safety. Finally, I present the potential key issues. As AI develops and becomes more integral with geospatial visualization, could there be a risk of too much trust imposed? AI provides misleading or incorrect information that may compromise the accuracy and safety of what users need. Also, there could be a risk of reduced knowledge and skills from too much reliance of AI and automated methods, potentially limiting the skill and experience development. The alternative is an increased user availability, allowing for more inexperienced people to utilize geospatial information easier. This leads into the next point, where if the digital systems were to fail, would the preparedness level be readily enough to resort back to alternate methods such as physical maps and charts again? Lastly, a great issue involving the costs. The cost of resources required, the financial cost, and how it will impact the environment. Would it lead to more problems than solutions? Thank you for listening.